right, our last lesson in this unit is on Venn diagrams. You may have actually seen Venn diagrams in some of your other classes, particularly in history or government classes. Sometimes in English class, when you're setting up a paper to compare and contrast two different things. So our essential question is, how do I read and create Venn diagrams? All right, a Venn diagram is a way to show logic statements in pictorial form or diagram form, graphic form. Okay, there are three main types of Venn diagrams. So let's see, objects in one loop have nothing in common with the objects in the second loop. So for example, let's say dogs and chairs. There's nothing in common between those two groups. Okay, so no dogs are chairs might be a statement. So no, not, none, all key words for nothing in common. Objects in one loop have some things in common with objects in another. So an example here might be, okay, we're going to overlap them to show that some things are in common. Let's say students taking math and students taking science. Now what this means is that some students take only math. This part of the loop would represent students taking only science. And this overlap here in the middle would be students taking both. Okay, that's one option, and that is the intersection option of a Venn diagram. We're looking at the intersection where the two connect. Okay, a key word for that would be and or both. All right, another option here. Again, we have interconnecting circles, but this time we're interested in everything in both circles. So again, if we look at math and science, we would be interested in or, students taking math, science, or both. So it would be everything in both circles. We'll talk more about intersection and union. And let me go ahead and say this is a union example. And this is an intersection. We'll talk about both of those a little more later. Okay, the third type is when one loop is completely inside another. The key word for that is all. So for example, if we look at let's see, people taking math and students. Okay, all people taking math are students. Okay, so students is a subgroup. You could be taking something else, but all, ooh, I did that backwards. I am sorry. If you're taking math, you have to be a student. Okay, So math is contained inside. Out here in the student circle, you could have people who are taking English or science or history or an elective. But if you are taking math, you have to be a student. Okay, so use the Venn diagram to fill in the blank with the correct qualifier, all, some, or none. Let's see. Cloudy days or rainy days? Well, I mean, here I could be out here, I could have no rain. So sometimes we have rain, sometimes we don't. So some cloudy days are rainy days. Okay. Rainy is completely contained inside cloudy, which means in order to rain, you have to have a cloudy day. So all rainy days are cloudy days. Looking at the next one. People who go to the beach, and that overlaps with students. So that means some people who go to the beach are not students. Some students don't go to the beach. And some of the people who go to the beach are students. So some students don't go to the beach. That would be this section of the Venn diagram right here, because that's the part that does not overlap with people who go to the beach. People who go to the beach are students. That's right here. It's in both circles. So some people who go to the beach are students. And then this part I didn't shade in at all would be people who go to the beach that are not students. Let's see, right angles are obtuse angles. Is there any overlap between these? No, there's not. So no right angles are obtuse angles. They're completely separate circles. Obtuse angles are right angles. Again, they're completely separate. So no obtuse angles are right angles. Right angles are angles. Well, right angles are completely inside the angles loop, so all right angles have to be angles. All right, getting a little more complicated. Field hockey players are football players. So is there any overlap between field hockey and football player circles? No. So no field hockey players are football players. Basketball players are athletes. When I look at it, the basketball player circle is completely inside the athlete circle, so all basketball players have to be athletes. Sorry, baseball. I kept saying basketball, but it's baseball. Baseball players are football players. Okay, well, those two circles overlap. So if you're playing baseball and football, we're talking about this section right here. So some baseball players also play football, but some don't. Now let's try to go the other direction and draw one. No apples are bananas, so I don't want any overlap. Apples, bananas, and no bananas are oranges. Okay, I don't want any overlap. You have to label your loops. That's very, very important. Some animals are cats, and no dogs are cats. Okay, so we have animals and cats. There has to be some overlap here. Animals and cats. And this is the sum part, the overlap. No dogs or cats. Dogs, however, are animals. So I'm going to put my dogs inside the animals. Okay. I could have also drawn this, so that's one way. Could have also drawn this, animals, cats, and I could put dogs out separately, but I really need to think about that. Dogs are animals, so they're best inside the other circle. You could draw it separate, but it's not the best way to draw it. And that's something we have to think about every time we're doing one of these. Some students who take math also take English. So some means I'm going to have overlap. I've got math, the most important class, of course, English, and I'm interested in this group that take both. So now let's talk specifically about the special types or kinds of overlapping Venn diagrams. There are two special kinds that overlap. So the union means we are looking at everything in both loops. Keywords or and both. Okay, so when we go to shade that, and I'm going to break out the highlighter here. When we go to shade that, I need everything in P and everything in Q. Okay, you can shade it with the scribbles and the stripes like I've done on earlier ones. The highlighters tend to be not mess up what you have inside, so that's another option. Intersection means we're looking at the overlap. Okay, so the keywords here are and let's see, or and, sorry, both. Better word up here would be all. So here, I'm only looking for the overlap, which is right here in the center. So shade the region in the Venn diagram. Some students take both math and art. So I need math and I need art. You have to label. And I want some that take both. That means I want the overlap. Okay. People who play basketball and take violin lessons. And basketball, violin. Okay, and so they're doing both things. They are here in the middle. Busy people. Months with 31 days or months that start with J. Okay, or means all or union. So I want all the months with 31 days and all the months that start with J. People who drive cars but not motorcycles. Oh, this is an interesting one. Cars, motorcycles. And I say it's interesting because of the word not. So cars would be this whole loop here. Okay. But I do not want the part of the loop that has motorcycles in it. So I have to take out the motorcycle part. Now sometimes, and very frequently, especially on the SOL, you're given a Venn diagram that has a lot of numbers in it, and then you're asked to answer questions about that Venn diagram. So our example here on a recent survey, students were asked if they ice skate, snowboard, or ski. So here are our skaters in this loop. Here are our skiers in this one. We've got snowboarders out here. And then we've got a random number that's not in any loop. So let's talk this through. How many students ski or snowboard? Or, that means I need all the numbers in both circles. So skiers, I've got 13 plus 2 plus 3 plus 8. All the numbers in green. 13 plus 2 plus 3 plus 8. And I have to add the numbers in the red circle that I haven't already included. So 3 and 8 are here, plus 4 plus 10. So let's see. Didn't have my calculator ready. 13 plus 2 plus 3 plus 8 plus 4 plus 10, 40. 40 people skate or snowboard. How many students ice skate and ski? And is the key word, meaning they do both. So I want the overlap of ice skating and skiing. I want the overlap of the blue and the green. So that's 2 plus 3, which is 5. How many students ice skate, ski, and snowboard? That means they're doing all three. I need the number that is in all three circles. That happens to be 3. How many students do not ski or ice skate? Okay, so that means I want the numbers that are not in either circle. Okay, so outside of ice skating, outside of skiing, that's the 10 people who only snowboard, and these 6 people out here who don't do any of those 3 things. So 16 people total. How many students just snowboard? Okay, so that would mean they are only in the red circle. They're not in the overlap of blue or green. And that is just plain old 10. Our next question. How many students do not ice skate, ski, or snowboard? So I'm looking for the value that is not inside any of the circles at all. Okay, there are people who don't do any of this. That would happen to include me. I don't do any of this. And that's out here. All by itself, there are 6 people who don't do these 3 activities. How many students ice skate? So I want all the numbers in the blue. 7 plus 2 plus 3 plus 4. That's 16 people ice skate. How many students do not snowboard? So I want every number that is not inside the red circle. So the 7, the 2, the 13, and don't forget the 6. Okay, those 4 numbers are not in the red circle. So we've got 22, 28. And how many students took the survey? Okay, that's every number up here. So 7 plus 2 plus 13 plus 4 plus 3 plus 8 plus 10 plus 6. There were 53 people in this survey. And being the overlap, or being everything in the 2 circles, okay, not being outside the circle, Color can really help you figure this out. Very useful. And it looks like we are done with this lesson. Please write a summary for me.